Let's take a look at another example. The federal hourly minimum wage was $4.25 in 1995 and $4.75 in 2000. This data came from the U.S. government. Suppose I'd like to find a linear function, w equals f of t, that models the data, and I'm going to use t equals 0 as 1995. So to find the linear function, what I'm first going to do is find 2 points. And I was conveniently given information that'll give me 2 points. Each of those points are going to be of the form t comma w. And I know t equals 0 is 1995, so I will have 0, comma 4.25, and then I will have 5, comma 4.75. So now to find the equation, again I compute the slope, change in y over change in x, but instead of y this time I have w, so change in the wage over change in the time, because I have time instead of x. So if I do the math out, 4.75 minus 4.25 over 5 minus 0 gives me 0.50 over 5, or 0.10. And the units there would be dollars per year. So on average, the minimum wage went up by 10 cents per year. Now, to write the equation, use y equals mx plus b. So y equals 0.1x plus b. But notice, they gave me b. The y-intercept is right here. So my y-intercept is 4.25. Now the last thing I'm going to do is write it with the proper letters. So what I know is w is 0.1t plus 4.25. Now part B. I want to use my formula to find the average hourly wage in 2008. So 2008 gives me t equals, well, let's see, 0 was 1995, so I would take 2008 minus 1995, which appears to be 13. So I'm going to use t equals 13, and I'm going to substitute that into my formula. So 0.1 times 13 plus 4.25. Take out my calculator. 0.1 times 13 plus 4.25 gives me 555. So the question is if the current minimum wage is $6.55, is our linear function reasonable? And the answer is no. Notice that actual minimum wage grows or grew faster. Right? We'd rather have the actual rather than what the formula gave us.